All right, so today we're going to be talking about triangles being similar. Okay, so let's take a look. Now, I remember that for congruency, right, when the triangles were same shape, same size, we had a bunch of formulas. Remember side, angle, side. Like we had a few formulas that did work. Now, for similarity, we have only a few. We have a lot less. We're going to use, one of them we're going to use is called side. Let's see, side. The other one we're going to be able to use is going to be side, angle, side. That's the other one that works. And there is a new one, right? There's a new one. I remembered I covered for triangle congruency. There's one rule that we said that didn't work, angle. Right? We said that one didn't work because back then for congruency, we needed the triangles to be same shape, same size. Angle gave us the same shape, but not quite the same size. Now, the interesting is that similarity is only same shape. It doesn't care about the size. So angle will work. The only thing is that we believe that if two angles of one triangle are congruent, then the third one has to be congruent as well. So we don't need all three angles. We're going to only use two angles. So angle is the one rule that is going to work. So we're going to use side, side, or angle. When we're talking about sides, when we use sides, make sure the sides are proportional. We talked about proportional before. You can make fractions and simplify them. They simplify to the same thing, or you can cross multiply, but sides have to be proportional. Angles, when you use angles, the angles have to be congruent. They have to be the same side, the same number. So here, I'm looking at questions 11 through 14. It says, state if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. So I see my triangles given. I see that I have sides and I have angles. I have 39 degrees here and I have 39 degrees here. So those angles are equal. Now I see I have some measurement about sides. So on the top triangle, I see the numbers 18 and 28. So let's see. Let me see if those sides are proportional. 18 and 28. I'm going to use those two numbers. And I'm going to say 18 is corresponding with 9. And 28 is corresponding with 14. Some of you might be wondering, how do you know? How do you know 18 goes with 9 and not 14? Now, the interesting is that I put my numbers from small to large. Right on the top, 18 and 28, I put them from small to large. And at the bottom, 9 and 14 as well, from small to large. All right, so I'm going to check if these things are proportional. I can cross multiply 18 times 14 and then 9 times 28. If these are proportional, I will get the same result. Another way I can check for these numbers to be proportional, I can simplify my fractions. And I'm going to do it that way instead. Like I said, we can cross multiply. You can do it, you can pause the video and you can do it at home. 18 times 14 and then 9 times 28. If you get the same number, they are proportional. If you don't, then they're not. Like I said, in my case, I'm going to simplify the fractions. 18 over 9, I simplify that as 2 over 1. 28 over 14, that simplifies as 2 over 1. So my sides are proportional. The angle that I'm dealing with is the same number. So I can deal with side, angle, side. If you notice, I have two sides per triangle, and I have the included angle. So I will be using side, angle, side. Now, interesting is when I complete the statement, right now I just said they are similar. Because they are similar, I'm going to complete the statement. When I complete the statement, the order of the letters does matter. So here I said RQP, that's how I start the statement, RQP. It's corresponding, it was similar to, now my other triangle, I'm either going to call it ABC, BAC, CAB. There's a way I'm going to use all three letters, but the order does matter. Okay, so let's take a look. The other one starts R. So the first letter is R. And I know R is corresponding to A. So my first letter will be A. And then it says the second letter is Q, right? But think about it. I'm using the side RQ. I got to ask myself, is this the big side or the small side? Right? I had two sides, two measurements to begin with. Now this is the big side. Therefore, I'm going to use the side AB. So it's going to be the triangle ABC. So RQP, that triangle RQP is similar to ABC. The order of the letters does matter. If we type in BAC, it's not correct, or CAB is not correct. It has to be ABC. Then I'm going to say by, then side, angle, side. So I completed the statement. And I'm including also which rule was I using, side, angle, side. Notice how the three letters for the triangle ABC, they're all capitalized. And then side, angle, side, they're all capitalized. Only the word by is lowercase. Okay, let's take a look at another example. I see no measurement of sides here, but I see 70 degrees. It's right here with 70 degrees here. Now, the interesting part is that I see two triangles. Here's one triangle, and here's the other triangle. Okay, so those are the two triangles I'm going to be looking at. Now, angle T, I'm just going to mark angle T because angle T, I have no idea how big angle T is, but angle T from the small triangle, let me remind you guys of the small triangle, is equal to angle T from the big triangle. Again, I don't know how big is it, but it's the same corner, right? Angle T is the same corner that is used for both triangles. So I'm going to say angle T is marked as well. I can mark angle T because they both use it. And if you notice, on the small triangle, I have two angles marked. On the big triangle, I have two angles marked. All right, angle is enough. So here, so let's see. I'm going to say these are going to be similar by angle. So here we have TSR. That is the big triangle. Let me do it better than that. So TSR is the big triangle. And I'm going to say this is similar to TLK, all capitalized for TLK, by angle. Okay. Oh, no, my bad. It's not TLK. It's TKL. Now, some of you are like, how do I know? How do I know? Okay, so let's take a look. Angle T from the small triangle is the same as angle T from the big triangle. So we're going to start at T. But my measurement here says TS. Right? TSR. You notice I'm going this direction. So I have to go TKL. All right, so TKL by angle. Okay, always double check. Now let's take a look at number 13. One thing I remembered, vertical angle theorem. When there's an X form, opposite angles are equal to each other. So this angle is equal to this angle. So I have one angle from each triangle. I see two sides. I'm going to try to go for side angle side. You notice I have, it looks like side angle side. Now, in order for me to use angles, they have to be equal, which is good. But in order for me to use sides, they have to be proportional. So the measurements of the small triangle are 11 and 12. I'm going to write them from small to large. The measurements for the big triangle are 23 and 24. 23 and 24. Now, two ways how to check if they're proportional. Simplify your fractions. They should simplify to the same thing, or cross multiply. Right? 11 times 24, and then 12 times 23. Whatever you get on the multiplications, if they are similar, they should be the same thing. In my case, I'm going to simplify my fractions. 12 over 24 is 1/2. 11 over 23, it's 11 over 23. It's not 1/2. It's just 11 over 23. I cannot simplify that fraction. So if you cross multiplied, you should find out that you get different answers. So my sides are not proportional. My angles are the same, but my sides are not proportional. Therefore, these are not similar. Now, for not similar, I don't have to complete the statement. I'm not going to complete the statement because they are not similar. I'm just going to write not similar. Make sure you capitalize the N from not, but not the S from similar. Our English classes, they usually tell us that when we're going to start writing a sentence, when we start writing something, we only capitalize the first letter. So capitalize the N, but not the S, all right? This is not similar. All right, let's take a look at question number 14. Now here, I see 3 sides per triangle. I'm gonna try to go for side. Okay. Now, when I look at the measurements of the small triangle, let me write them from small to large. I have 15, 24, and 27. I'm gonna use the 3 sides of the small triangle. Now, the 3 sides of the big triangle, I'm gonna write 25, 40, and 45. Notice I went from small to large, right? It's easy for me to tell which angles, which measurements corresponding to which measurement, right? The measurement of one triangle is corresponding to the measurement of the other triangle. It's easy for me to tell because I go from small to large. Now, I can cross multiply 2 fractions at a time, or I can just simplify them all. I'm gonna simplify. The first fraction, 15 over 25, let me divide each number by 5. So this gives me 3 over 5. 24 over 40, let me divide each number by 8. That gives me 3 over 5. So far, so good. 27 over 45, let me divide each number by 9. So I get 3 over 5. Notice how all my fractions simplify to the same thing. So the sides are proportional. So I'm going to complete this by side. Now, order matters, right? So I went A, B, C. That's the measurement that they're giving me, A, B, C. Now, A, if you notice, that's the medium angle. A, in this case, is corresponding to A from the other triangle. Some of you might be wondering, how do you even know? Okay, look at the bottom triangle, right? The triangle ABC. A is in between. The measurement that I'm using is the small measurement, 25, and the big measurement, 25 and 45. The small measurement and the big measurement. So I'm going to use 15 and 27. That's how I know here it's A. Now B. Let me ask you guys this. Think about it. Am I going to complete this as AML or ALM? Like, order does matter. What's my second measurement? M or L? What's the second letter? Is it going to be AML or ALM? All right, let me help you guys out. So for the second letter, I see the measurement here at ABC, right? So the first two letters are AB. That is the smallest measurement of the triangle. So here I'm going to use AM. So I'm going to complete this as AML by side, side, side. If I go ALM, it's wrong. Like I said, the order of the letters does matter. Okay, so those are the first four that we're going to be covering. Like I said, today I'm working up until 22. So let's take a look at number 15 through 18. All right, for the four that I just covered, 11 through 14, if you need help, you know where to find me. More likely you will need help. It's not an easy task. Okay, now question 15 through 18. Find the missing length. The triangles in each pair are similar. So I already told you the triangles are similar. Now, what we're going to be doing, I'm going to look at one side of my triangle. I'm looking at the side that is all numerical. I see the big side is 121, and I see a small side there is 44. So I'm going to subtract those two values. 121 minus 44, I get 77. So then I'm going to say this side right here, it is 77. Right, my sides are not made proportionally, or are not made to scale. Okay, so one side is 44, the other one side is 77, and I know because when I add those 77 plus 44, it's equal to 121. I might use the 77, I might not. So I started from the one side that it's all numerical. I'm finding the missing length. The question mark that I see, let me call it X. So I'm going to solve for X. I want to know what's the value of X. Now, what I'm going to see, I'm going to use from one side of my triangle, I'm going to use X, and I'm going to use 40. Okay. So I'm going to make my two proportions. I'm going to use X, and I'm going to use 40. And those two measurements are corresponding to two measurements on the other side of the triangle. Now, X is going to be corresponding with 121. X is the whole thing. So X is corresponding with 121. And then 40 is corresponding with 44. Again, earlier I said the 77, I might use it, I might not. There are some measurements that I don't need to use. Now, cross multiply. Simplify if you want. First, that way you're dealing with small numbers. I see the fraction 40 over 44. I could divide each by 4. Now, let me say something really quick. When we multiplied like this, right? We cross multiplied. So that's the only way we cannot simplify. We can simplify any other way. The fraction 40 over 44, you can divide by 4. At the bottom, the numbers at the bottom, 121 and 44, we can. 121 and 44, I could divide each by 11. Diagonal is the only way we cannot simplify. But I could simplify this way. Right? The way we multiplied is the only way we cannot simplify. So just to say that we can, I'm going to simplify a little. So I have X over 11 is equal to 40 over 4. Notice 121 and 44, I divided each by 11. So I could simplify. You don't have to. Especially if you're using a calculator, you don't have to. So I'm gonna say that that's it. I'm not gonna simplify anymore. I'm just gonna cross multiply now. So I'm gonna have 4x is equal to 440. I cross multiplied. 4 times x equals 11 times 40. Now let me divide both sides by 4. And I'm going to get that x is equal to 110. Okay, not bad. Let's take a look at number 16. I look at my x value. It's right there. Remember the question mark, I call it x because we learn in algebra that when we don't know a value of something, we call it x. So from that small triangle, I'm going to be using the values x and 10. From the other triangle, I'm going to use the numbers 24 and 40. Now, x goes with 24 or 40. The way we're going to know. Okay, so let's see. If you can tell, here I have x, and here I have 10. If you can tell which one's bigger, I'm going to say the small number goes with 24 and the big number goes with 40. Right, because on the other side, we have 24 and 40. The small number goes with the small number and the big number goes with the big number. If you can already tell if x is smaller than 10, x goes with 24. If x is bigger than 10, then x goes with 40. If you can tell, you can tell. Now, if you cannot tell, I'm going to say, all right, this is x is the side UV. That is using the first two letters here, UV. When I use the first two letters on this other side is CB. So x is going to go with 24. Either use which side is bigger or use a notation, right? That statement at the top, CBA, similar to UVW. I give it to you guys when the measurements are hard to tell. So x goes with 24 and 10 is going to go with 40. Now just cross multiply it and solve for x. I'm not going to simplify. We could simplify, but I'm not going to. I'm going to use a calculator here. So when I cross multiply it, I'm going to have 40x is equal to 240. All right, I went 40 times x and 24 times 10. Now let me divide each side by 40. So x is equal to 6. Okay. Let's take a look at number 17. Let me highlight this side. X is on this other side. But I'm highlighting one side of my triangles because it's all numerical. The big side is 45. A small side is 27. I know 45 minus 27 is 18. So I'm going to say the measurement MW is 18. Right? I'm going to write that 18. I might need it. I might not. I'm going to keep it there just in case. All right. So from the one side that it has the X, I'm going to use X, obviously, and I'm going to use 35. So X and 35. I'm going to use those to solve for X. Now, X is corresponding with 27. So X goes with 27. 35 is the whole side. So 35 goes with 45. Now I'm just going to cross multiply. We can simplify if we wish, but I'm just going to cross multiply. So I have 45x is equal to 945. If you are using a calculator, I recommend just cross multiply. If you're doing it by hand, I'd recommend simplify. That way you're going to deal with smaller numbers, right? 35 and 45, I would have divided each by 5. That gives me 7/9. sideways, 27 and 45, I would have divided each by 9. Okay, so I have the 45x is equal to 945. Let me divide each side by 45. So I get that x is equal to 21. Okay, found the value of x. Take a look at number 18. I'm going to say the measurement DW is 12. All right, based on the side, they're all numerical. 12 plus 16 is 28, so that's why I know that's 12. So now I'm going to use x. Remember that question mark, I always call it x. I'm going to use x and 35. So x and 35. X on the other side of my triangles is corresponding with 16. So x will go with 16. 35 is corresponding with 28. So 35 goes with 28. Now I'm going to cross multiply. Again, you can simplify first. I'm just going to cross multiply. I have 28x is equal to 560. 35 times 16. That's how I got the 560. Let me divide both sides by 28. So x in this case is going to equal to 20. Not bad. Not bad. Now let's take a look at the last 4 questions. Let me stop this share. Okay, so 19 through 22. Solve for x. The triangles in each pair are similar. Okay, so I'm going to say the measurement RG is 7. My focus was on the side that is all numerical. The big side is 14, a small side is 7, so RG is 7. I might need that 7, I might not. I'm just going to use it. I'm just going to write it there. So x plus 13, I'm going to use on one side x plus 13 and 10. So x plus 13 and 10. Now x plus 13 is the whole side. So that goes with 14. 10 goes with 7. Now I'm going to cross multiply. When I multiplied this way, because of the plus sign, right? There's x plus 13. When there's a plus sign, the number by itself will have to go to both numbers, both terms. So 7, I'm going to go 7 times x and 7 times 13, okay? So that's going to give me 7x plus 91. Right, 7 times x gave me 7x. 7 times 13 gave me 91. So I have 7x plus 91 equals, when I go this other way, 14 times 10 is 140. Let me separate my sides through the equal sign. I want the 7x by itself. So the plus 91, let me move it to the other side as a minus 91. Let me not forget to switch the sign. So that's going to give me that 7x is equal to 49. Right, 140 minus 91 is 49. Let me divide both sides by 7. So I get x is equal to 7, right? 49 divided by 7 is 7. Let's take a look at question number 20. All right, from one triangle, I'm going to use 13x minus 2 and 70. So let me just write that down. 13x minus 2 and 70. All right, 13x minus 2. Does that go with 56 or does that go with 40? If 13x minus 2 is smaller than 70, right, I look at my two measurements. If 13x minus 2 is the small side, then it goes with 40. If 13x minus 2 is the big side, it goes with 56. If you can tell the measurements, which one's bigger, which one's smaller, then you can match them. Now, if you cannot tell, 13x minus 2 is the side GF. I'm going to use the notation on the top. GF or FG are the first two letters here. So that goes with FS. So 13x minus 2 will go with 40. And 70 will go with 56. Again, you can simplify if you wish, right? 70 and 56, I will divide each by 7. 40 and 56, I will divide each by 8. But because we're going to be using a calculator, I'm not going to simplify. I'm just going to cross multiply it. So I'm going to multiply this way. Because of the minus, right, 13x minus 2, I'm going to go 56 times 13 and 56 times 2. So that's going to give me 728x minus 112 equals, when I go 40 times 70, I get 2,800. The numbers might be big, but we're using a calculator. If you don't want them that big, we can always simplify. All right, so let me separate my sides through the equal sign. The negative 112, I'm going to move it to the other side as a positive 112. So that's going to give me 728x is equal to 2,912. Now let me divide both sides by 728. And I'm going to get that x is equal to 4. All right, let's take a look at number 21. I see where x is, so I'm going to use the measurements 8x plus 2 and 99. So 8x plus 2 and 99. Now, if 8x plus 2 is smaller than 99, it goes with 30. If it is big side, it goes with 45. If you cannot tell, then use the notation. KL, right? 8x plus 2 is the side KL, which if you notice are the first two letters here. So that's going to go with FE. So 8x plus 2 goes with 30, and 99 goes with 45. We can simplify anytime. I'm just going to cross multiply it. Because we're using a calculator, I'm not going to simplify. I'm just going to cross multiply it. Because of the plus sign, I'm going to go 45 times 8 and 45 times 2. So that gives me 360x plus 90, right? 45 times 8 gave me 360, and 45 times 2 gave me 90. Now, the other way, I'm going to go 30 times 99, and that's going to give me 2,970. Okay. Let me separate my sides to the equal sign, the plus 90. Let me move it over as a minus 90. So that's going to give me that 360x equals 2,880. Let me divide by 360. So I'm gonna get x is equal to 8. Okay, nice. Remember, you can always simplify your fractions. Let's take a look at number 22. From one triangle, I'm gonna use the measurements 4x minus 14 and 36. From the other triangle, I'm gonna use the measurements 35 and 40. Now 4x minus 14, if it is the big side, it goes with 35. If it is the small side, it goes with 30. If you can tell, then just move on. If you cannot tell, then we're gonna use the notation. That is the side. 4x minus 14 is the side GH. You notice those are the first two letters on my first triangle. So GH is gonna go with the side VH. Now VH is 35. So 4x minus 14 is 35, and 36 is gonna go with 30. Now some of you might say, well, I could tell. I was able to tell that 4x minus 14 was bigger. Then it goes with the bigger measurement. If you could tell. Okay, so now we're gonna multiply. We're gonna cross multiply. We can always simplify, but I'm assuming you guys are using a calculator, so I'm not gonna simplify. When I go this way, because of the minus, I'm gonna go 30 times 4 and 30 times 14. So that's gonna give me 120x minus 420 is equal to, when I go this other way, 36 times 35 is 1,260. All right, so let me separate my sides through the equal sign. The minus 420, let me move it over as a plus 420. So I have that 120x is equal to 1,680. Let me divide both sides by 120. So I'm gonna get that x is equal to 14. There you go.